Today we're going to go over linear graphing day 2. So our objective is to be able to understand and comprehend what the key features of a linear graph are. And then we're going to be able to use the content vocabulary in our language objective. Those vocabulary terms are increasing and decreasing. We saw that on day 1. A new vocabulary term here is end behavior, and we'll talk about that when we get there. And domain, range, x-intercept, and y-intercept. And those are 4 terms that we saw in the last set of notes. So let's start off by just going over what domain and range are. So if you'll remember, domain has to do with your x values. And we talked about this on day 1, where we said the domain is the smallest x to the largest x. So smallest x, comma, largest x. And so remember, domain tells you how far left and right. So remember, that's left and right. So how far left and right, that is the domain. So it's how far left and right your graph goes. Whoops. So how far to the left and how far to the right. The range, remember, that's your y values. And if we want to write this in interval notation, it's the smallest y, comma, largest y. And remember, the range tells you how high up and how far down. So how far down and up. So range has to do with up and down, domain has to do with left and right. So pause if you need to finish writing this down. The next 2 important terms that we're going to see a lot today and use today are open and closed. So when we say open, what we're essentially saying is that you would see an open circle. And remember, we saw this way back when we did graphing inequalities. Remember, when we graphed inequalities, we said if it's just the inequality sign with no equal to sign, so if it was one of these, then we said, okay, you have an open circle there. So it just meant that that value was not included. So that value was not included. So you would see in set notation, you'd see parentheses like that. Closed, remember, just like with inequalities, that was represented a closed circle. Well, I guess I'll show you what those circles look like. So here's a closed circle. And then I'll show the open circle looks like that. So closed circle, and that's where you would have the equal to sign underneath the inequality. And remember, that meant that the value was included. And that's what we did when we did solving inequalities. This time, though, when a value is included, this is very important. When a value is included, we use the brackets. And I touched on this a little bit in the previous video, and now you see why. When we're including a value, you need to use brackets. So we will come across both of these situations today, where you'll see open circle and closed circle, and you'll need to remember that you use parentheses for open circle, bracket for closed circle. And you also need to remember these inequality signs. So pause the video if you need to and finish copying this down. So the last question is, how can you tell if a graph is a function? For this one, remember, we use what is called the vertical line test. So it's the vertical line test. So it says if I draw a vertical line, any vertical line through the graph, the vertical line can touch in only one spot. So So does a vertical line touch in only one spot? So let's see some examples. So I want to tell you, you will see some examples from here on that have graphs. A good sketch of the graph will do in your notes. The important part is the questions that I'm going to ask you about the graph. So if you get a good sketch in your notes, you will be all set. So I'm going to change this so we can see 2 pages at once, just so we can see the graph and the questions. So the first question wants to know does this graph here represent a function? So that's either yes or no. So that means if I draw a vertical line through the graph that I'm given, does it touch only once? So here's a vertical line, I draw it, and it touches once, so it's a function. So we're going to say yes. Is the function increasing, decreasing, or neither? So remember, this is like a linear line. So this one is increasing, and it's increasing because it rises from left to right. So this is an increasing graph. The domain. So remember, the domain is the smallest x to the largest x. So if I look at the graph I'm given, so this from here, let me show it in red, from here to here, this is my graph. So if I look at that graph, what is the smallest x value? So hopefully you see it's right here, it's at -1. So my graph doesn't go anywhere beyond -1, it stops there on the x. So I'm going to write -1. Notice what type of circle it is. It's a closed circle at -1. So if it's a closed circle, we need to put a bracket at -1. So that's how far left. Now let's see how far right this goes. So here's as far right as it goes is over here. It doesn't go anywhere beyond this point that I'm shading in. So 1, 2, 3, 4, 5. So it goes as far right as 5. And notice that's a closed circle, so it needs to get a bracket. So this is interval notation. If we want, we could write it as an inequality that our x has to be between -1 and -5. So it says x is bigger than or equal to -1, and x is less than or equal to 5. So that was your domain. So that, remember, that had to do with the x-axis. Now let's look at the range. Remember, that has to do with your y-axis. So now you're looking at, instead of left and right, now you're looking at up and down. So we'll start with the lowest, which means how far down does this graph go? So on the y-axis, it goes as far down as this point here. So this point is -1. So it goes as far down as -1. And this is a closed circle, so I'm going to put a bracket. Now the range, how high up does the graph go? So the graph goes as high up as 1, 2. So on the y-axis, it goes as high up as 2. And then it needs a bracket because it's a closed circle. So that's interval notation. If I want to use an inequality to represent the range, it would be y is bigger than or equal to -1, and y is less than or equal to 2. So the next part, end behavior. So as x approaches -infinity, what happens to y? Well, x doesn't really ever approach -infinity because there's no arrows going to -infinity, like there were in the notes on day 1. So here, end behavior really doesn't apply, so we're going to just ignore the end behavior part for these notes. But we can answer the x and the y-intercept. So the x-intercept, remember that's where the graph crosses the x-axis. So this graph crosses the x-axis probably about here. So let's just call that, I don't know, let's call that 2/3, 0. And then the y-intercept, where does the graph cross the y-axis? So here's the y-axis. The graph crosses about here. Let's just call that -1/3. So we'll call it 0, -1/3. So those are just approximations. This is fine. I'm sorry, I have this backwards. So we have 2/3 comma 0. This is the x-intercept, and this is the y-intercept. Sorry, I had that backwards. So this should be the x-intercept. Oops. And that second one's the y-intercept. My mistake. So the next example is this one. Again, pause the video, give this a quick sketch. Doesn't have to be perfect, but just get a good sketch down. And then if you're going to copy the questions right away, you don't have to remember, we're not going to do the end behavior part. So, first it wants to know, is it a function? So that means, can I draw a vertical line through this and it will only touch one time? So I draw a vertical line, it touches exactly once, so it's a function. So we're going to say yes, it's a function. Is it increasing, decreasing, or neither? Well, this is just a straight line, so it's neither. It's not increasing and it's not decreasing. So why? Because it's a straight line. So it's a straight line. The domain. So remember, domain is smallest x to largest x. So what's the smallest value of x? It's right here. So it's -2. And that was a closed circle, so I'm going to put a bracket. And then what's the largest value of x? So how far right? So here's my x-axis. I go as far right as 1, 2, 3, as far right as 4. But notice at 4, I have an open circle. So I'm going to put a parenthesis. So this is interval notation. The way we would write this as an inequality is x is bigger than or equal to -2. And this should say x is strictly less than 4 because it cannot equal 4. So this should be a strictly less than 4 sign. So that's your domain. The range, remember the range is the y-axis. So that's how far down and how far up. Well, notice my only y value is right here. It's at 3. So for the range, my y value is always 3. So I'm just going to write 3, 3. And you would use brackets for this one. So 3, 3. And the reason being is that 3 is your only y value. So y is, if you want to write it as inequality, y is bigger than or equal to 3, or y is less than or equal to 3. So you'd write it like that. The next part, the y-intercept. Well, the graph definitely crosses the y-axis. It crosses right here. So this is a point 0, 3. And the x-intercept, there is none. So let's go on to another example. Again, if you get a good just a rough sketch of this graph, that would be perfect. And then we can answer these questions. So here's my x, here's my y. Actually, so is this a function? So if we do the vertical line test and we draw the vertical line, it touches in exactly one spot. So yes, it's a function. Is it increasing, decreasing, or neither? It's increasing because it rises from left to right. Now, I want you to try the domain, range, and x and y-intercepts on your own. So I'm going to cross off the end behavior. Remember, you don't have to do that part. But I want you to try domain, range. So I want you to try these ones and these two. I want you to try them on your own. So pause the video and give those a try. All right. These next few examples are what we call piecewise functions. So In other words, it's saying I'm giving you now one or more functions in one graph. So I'm going to identify what each piece of this graph represents. So what function each piece of this graph represents. You always start from left to right, just like you read a book. So 2/3 x plus 16/3 is represented by this piece. So I'm going to call this function number 1. Then the next function is going to be function number 2. I'll do that one in red. So here's function 2. It goes from here all the way down to here. So this is function number 2. And the last function I'll do in blue is just f of x equals 1. So it goes from here to here. That's an open circle. So for this, let's go ahead and find the domain. So I want you to find the domains of these. So for the domain, remember, it's how far left and how far right. So on just this green line that I have here, how far left does that green line go? So it goes 1, 2, 3, 4. It goes to -5. And I'm using interval notation. So it goes -5, and it's an open circle, so I'm going to have a parenthesis. And then it goes as far right as -2. And that's a closed circle, so I'm going to put a bracket at -2. So that completes the green function. Now I'm going to go to the red function. So the red function, I'm going to start it here at 2. And so at -2. And this time I'm going to use a parenthesis because I included it before, so I really shouldn't include it in both parts. It wouldn't technically be wrong if you put a bracket there, but notationally, we're going to want to put a parenthesis because we already included it with the first function. But it doesn't really matter. I guess you could put the bracket. It's not a big deal. So you could put a bracket there if you want. And then that will go as far right as +1. And then the blue little piece is going to go from 1 all the way to 2, and that's going to be a parenthesis. Next one, again, I'm just going to stick with finding the domain on these because that's what's usually used for these. So the domain, this time I'll use interval notate, or sorry, I will use inequalities to write the domains out for this one. So I'm going to start here. So this is going to be my first function. And I'm going to stop here. So I did that one in blue. The next function I'll do in red. So function 2 is just f of x equals 3. I'll go from here all the way to there. So that's function number 2. So the domain, so that's just your x's, how far left and right. So this goes as far left as -5, and that's a closed circle. And then the blue goes all the way up until here, so that's up until 0. And we'll include that. The red function, f of x equals 3, starts at 0. So I'll put 0, and then it will go all the way to 7. So that's what that one would look like. So I want you to try this one. So f of x equals 4. I'll identify the pieces for you. So this is function number 1. So f of x equals 4 is function number 1. F of x equals -3x minus 9. It's the green function here. This is function number 2. And then f of x equals -2 will be the purple one. So it's this function here. So I want you to give that one a try. For this one, please find the domain. So I want you to find the domain. pause the video and give it a try. When you unpause it, I'll have worked it out for you. So hopefully you took a second and gave this one a try. The intervals -10, -4 for the first function. -10 is included, -4 is not, because it's an open circle. For the next function, it's -4, -2. The -4 is included, and the -2 is not. And the last function goes from -2 all the way up to +4. So from -2 to 4, and both of those are included.